Hello, everybody. Welcome to another stream. How's everyone all doing? So last stream we got the script, the encoder generation script, working to the point where it can parse a C-like file that defines a bunch of C-like enum structures and other structures, with some extra little features, and then it will just basically print it back out based on the data that it has. So here you'd notice like we've not got the -1 here, but it's being inferred correctly. And we've got some extra like attribute things and bit packing fields and say, serialize this out as hexadecimal. So, and also we've got like a feature for an array, which is where the size comes from a structure field rather than an actual fixed array, right? So it's so we got this done last stream, but so now we should really start to try and use it by writing out a text writer where we're going to have the ability to take in these structures and then write out a text file like JSON, but not really JSON, because JSON has some specific design decisions I wouldn't really want to stick with for this project. But yeah, and we'll also do some other things which we'll get to in just a moment. Just welcome you guys. Hello guys, welcome, welcome. Oh, did I plug in my webcam? Hey, much better. Thank you, Glorious sir, appreciate it. I shouldn't live on default, you know. Good idea. How you doing, Glorious sir? Good to see you. Yeah, how's the MSDF stuff going? How you doing? Inumraya, welcome. It's been a while. Elwood J. Finley, welcome back. Welcome back. Yo, so good to catch a stream. Got looked at my old account, so I made a new one. Yeah, it seems like you just got an extra underscore or something. Thank you, appreciate it. Yeah, things are going good. I don't know if you've seen, but we've got we're taking a little break from the rendering side of things, because we literally just sort of did some core stuff, did some UI, and then did basically a bunch of rendering. So now we've done the rendering R&D, we've sort of found a sort of a direction I want to iterate in with these sort of ellipsoids and things. But yeah, I'm just building the big plan for the moment is to build an editor where we can make custom 3D models and stuff, and obviously make some little levels for testing purposes. But yeah, it's good. It's really good. I'm quite happy where we're at. Considering we spent 50 streams like setting up a ton of stuff, then 50 more streams, or more actually, probably at 70, just doing some rendering, research and development, just run a bunch of different renderers. So, most of the time has been on an R&D side of things. So now we're coming out of R&D and just doing more sort of features towards the game, which is good. So yeah, it's pretty good. I got a bunch of things we can pull from in the future, if need be as well, because I've already researched it. So it's pretty good. Yeah. Today we're working on our sort of custom encoding and decoding stuff, which is going to be used for file formats, networking, encoding and decoding, and GPU encoding and decoding. So I just code generate a bunch of useful functions that we just call. So yeah, we're going to work on our like C-like JSON writer today. We'll get started on that. But before we get started on that, I want to talk about last stream we finished the encoder file parser, but I now want to copy something from flat buffers because I read this over the weekend about flat buffers, and they have in their sort of format a thing called a strut and a thing called a table. So the thing that we have right now is like their tables. It is this sort of like variable sized structure that has optional, every field is optional and can have default values. So you don't have to include it in the final binary. But they have this good distinction where their structure is basically like, so the table has optional fields and default values, whereas a strut serializes the data that it contains, and that's it. So there's no extra metadata bits before the structure in any way to say which fields are there. So I think that's quite a good distinction, and I want to copy that. But I don't really want to copy how they've done their table encoding. So yeah, we're going to get started on that quickly by simply just making it so that structures cannot have these default values, but tables can. And that will be a good distinction because my GPU encoding stuff is going to be using structures because we just want to basically say, I've got a U16, I want to pack it down into 8 bits, right? And then there's a sort of encoding code and decoding code that gets code generated. And those you want to be structures because I don't really care about stuff being versioned or I don't really care about a lot of the time packing it down into a variable sized space. It's more like a fixed size space for GPU. So it's going to be useful there. And probably be useful for the file format stuff as well. Hey Devastated, how you doing? Yeah, I'm not doing bad today. A little bit tired, to be fair, because been getting up a bit early because the boy's been waking up early, so I do the earlies. But yeah, other than that, doing pretty good. Just had a pretty chill day yesterday. Actually, went out and bought more clothes, which is kind of rare for me. Because winter's coming and I don't have too many winter clothes. But yeah, how about you? How you doing? How's your weekend been so far? Right, so we just want to quickly change the parser. It's not a lot of work. So we'll go to the entity or encoder generator. It's basically so similar except for one letter. And where we pass a strut, we're just going to copy paste that code and rename it to table, and that's the table done. And then we literally just have to change how the structure works, right? So one thing that we're still missing is support for a union type. But for a union type, yeah, I don't really know. Sometimes they're better off being like a tagged union and stuff like this. So until I really need it, I'm not really going to think about it. But yeah, tagged unions and stuff could be a thing that we do. I don't think you can support a union. It'd be a bit weird. Right, so if we rename that one to a table, so this is the bit that is just the parser for that custom .enc file, which just describes the data that we're trying to encode and decode. So now we've said if it's a table, do all that code. Now it's saying if it's a strut, do all this code. So if we go back to the enc file, we need to copy and paste one. Let's put a 2 after it. But yeah, so basically a structure cannot have so we'll call this a table. Yeah, it doesn't really look like it was syntax highlighting, but oh well. So if we call it a table, this one can support default values, whereas this one cannot. So where we have the equal symbol, in places, There's the while loop. There we go. This is the structure fields. So where there's an equal symbol, I'm going to delete it. So actually, rather than deleting the if statement for it, what we're going to do what we're going to do is put an error in here saying a structure cannot have any optionals. Oh, then we've got to rename. Yeah, okay. We're going to do some refactoring for the table stuff now, though. Strat data types cannot have default values. I'm good, thanks. Pretty calm weekend for me. Just done some cleaning the house. Yeah, it's pretty standard. I remember when I was younger, I was like used to like hate cleaning, but now like I do every Saturday. It's quite alright. I don't mind it. You know, I wash the dishes now. The dishwasher died, and I remember I used to hate like doing all that stuff, but it's quite calm. You know, just put on a video, sit up by the side, and just clean some dishes. That's cool. Get the house in order. Got a rabbit hole of a preemptive preemptive optimization of encoding a quad transform for glyphs. And then wrote some with a matrix per quad thing. And I should have started there actually, right. Right. Oh yeah, is this 3D, isn't it? Is this like 3D? You didn't, it's in a like world space text. Or is it just 2D? Except for Season also gives me the heebie-jeebies. That's alright. Yeah. No, so I've done this format like every time I've written out like text-based serialization, and it's basically just JSON but just a C version, and it's pretty right. Does the job. Supports trailing commas, and it has the type names in the file as well. You know, like I do see why people use JSON because they want to get it. You know, they want to like use some utilities that support JSON or something, right? But I don't. Yeah, I'm not going to have that problem. So I would much prefer a nicer format. You know. Right. So that's the strut one adjusted. So we'll complain and say we can't have any default values as a strut does not have optional fields. So when we have that strut type thing, this thing, we'll just copy paste it. So I guess we'll do something like that, right? Strut table. So tables support default values. So the strut field one needs to get rid of its default value thing. Oh, I didn't finish the table thing. And then Finance 2D, but plan to do 3D later too. Right. Let's see. Yeah, you can just do yeah, you don't need the matrix, but yeah, I see what you're saying. The matrix is just easier just to get things going. But yeah, I think in my UI library, yeah, we do some crazy stuff in this. We UI.h. So where's the transform stuff? Oh yeah, we did pack it in as a 2D matrix. Yeah, so it was a 2D matrix because I support skewing. Yeah. So UI shape, scale, rotate, skew, because skew is kind of pretty funky. And it also obviously supports the translation, that's just... And so when I compute the matrices and put them in, I've got a function which I code generated with all the correct maths to do it. Yeah, UI transform. Matrix in it. Yeah, this is it. This is the craziness. So there's like a thing called a UI transform and the UI matrix out, which is a 2x3 matrix or something like that. And the transform has individual properties like scale, skew, translate, and rotation angle. And then this gets computed with a bunch of code generated maths from, it was some Python library that did it. Someone told me about it on stream. And then it just sort of makes the matrix for me. So I was like, boom. Yeah, produce the inverted matrix, and there's the non-inverted matrix. Oh, you did the same thing basically. Sweet. That's cool. Yeah, because you can store it as separate parameters with like, yeah, scale, rotate, and that, but you won't be able to get the skew, and that's about it. If you don't care about the skew, the separate parameters will be... Might be about the same actually, because a 2D matrix ain't that big, is it? Two. It's actually like more. Yeah. Yeah, you're like one less float maybe if you don't store the rotation as an angle. Oh no, it will always be an angle, right? Yeah, you're saving one float if you don't use the matrix. Whereas with 3D, I guess it's a bit more beneficial, isn't it? Fair play though. But it's fun. It's fun hyper optimizing stuff for no reason. I do way too much. What is the most optimal way? Let's do it. So, and I guess this is what helps with this encoder and decoder, is that I can basically like code gen the packing stuff for me when I want to pack, I guess. Be pretty fun. So yeah, we've got these separate things now, so I just gotta quickly find. So let's generate the arrays, the global arrays for these new table things. Right. And then let's get them initialized. Right, so struts, comma, that ought to do it. Table. Right, so now they're initialized. So let's get to where that table one is. And we just got to change everything for strut in here to table. And then we can test it all out and then be on our way. Table. Oh, we've also got to print out tables as well. That'd be a bit of fun. Right, strut, table. Oh, I need a new local variable for the formatter as well. Right, we'll get to that one in a bit. Let's finish up with the can find a replace here. Scrolling like a scrub here when I could just have found my way to this line. Right. Alright, that's good. So that's been all renamed, I think. Nice. So there's another one in the generator. Yeah. We've got to go ahead and table. Cool. So in that context-aware formatting, yeah, so context-aware print formatting. So we do the dollar and then an S. So we copy paste this. We'll get ourselves the table one. It's going to be basically the same as the strut, just a slightly different concept. Yeah, T isn't used. Good. So rather than strut, we say table. All right. Right. So it's not really a field anymore. It's more of like a table. Like maybe this shouldn't be called fields. Well, having different types for a structure in a table just seems a bit weird. So you know what we're gonna do? Maybe we're gonna get rid of. Yeah, because in like a standard C compiler, you typically have like a compound literal, which is a structure or a union, because they're basically the same thing. So let's just call it strut still. All right, and that'll do the job nicely, actually. All right, so let's undo some of the work that we've done. It's not that much. Should be it. Right, that'd be cool. So when we parse the, yeah. Right, so there's one more thing that we have to do, and that is like a table has optional values, which means it's a variable sized type, whereas a structure, once encoded, just encodes the fields, and that's it. There's no metadata to say which fields are there and not there. So a structure, by that definition, cannot contain a table, but a table can contain a structure. So we have to have a bit of error checking code about that, basically. So maybe we should have a boolean to say if it is a table or not. Right? So whenever you create this thing, you go, so zeroed, right, that's cool. There we go. So this is the table one, S is table equal true. So then when we parse the type for the field, you know, the code is basically the same now. It's making me think like I've just copied and pasted the code for no reason now. So maybe we should just say, do a sort of bit of an OR syntax. Is strut ball is strut equal that is table. So maybe we just delete the other code, to be fair. and then we just say is table equal is table. Because the code is basically the same except for the equal symbol, which I've changed now a bit. It's no biggie. Yeah, so if we take this and we go if is table, actually process the default value and store it in there. And then if it's not a table, put an error and say, well, struts can have default values, right? And then we'll just delete all the other code that we copied and pasted. All right, that's good. Because otherwise it's just extra crap we have to maintain when it could just be a simple if statement. Yeah, so I quickly just got to put back into the structure field the core string that represents the default value. And that should be it. Let's quickly go to the generate, sorry, where we debug print everything back out. So really we can just say, so this thing here prints out the word strut. I guess I can say if is table. We can just do something a little bit different. Right, I think that's it now. So let's give that a compile and run and see how it goes on. Hey Slow Kenny, hey, I'm kind of new to computer science, computer graphics. How important is data structure and algorithms for computer graphics? I know it's important for Counter-Strike, but not sure about computer programming. I don't know. I just butchered those acronyms. So basically, data structures and algorithms. You know, remind me again, because it's been a while since I've been through school and I went to a terrible one. Is that like your quick sort and your trees, like your binary heaps and your traversal algorithms and stuff like this, right? Is that what it is? Does it teach about like arrays and stuff like that? And like a hash table? I mean, I don't need this damn table thing as well. That's good. Oh, it's way better. So we just put if statements in. This is the way. Well, oh no. So tables are just like structures. So they use the same thing, basically, the same data type. That is good. Strict types are kind of, they're great most of the time, but when a type differs just a little bit, sometimes the strict typing is a pain in the butt. So it's good to always avoid it when you can. Yeah, I know it's equals computer science, I was just joking. Oh, computer graphics. Right, you meant for the other one. Linked list hash maps, cool. Well, basically, right, computer graphics is a very sort of like niche. There's lots of stuff you learn which you don't really apply into too many other places. You know, it's to do with like images of, you know, and colors, and you know, it's combining art and computer science together. And there's kind of there's other things, arts, physics, and like computer science together. It's quite a special niche. So I wouldn't try and sort of like convince yourself that you don't need to know things about how computers work, because how you achieve good graphics is you understand how to utilize the computer. Now, data structures and algorithms is probably, it's just your basics. Hash tables, linked lists, right? You're going to be using those, believe it or not, on GPUs in some cases, especially some of the high-end stuff, because they'll need to do some complicated things, and hash tables are a good way to speed things up. They're just your bread and butter of programming, really. I wouldn't shy away from learning a bit of, about arrays, trees, and hash maps. Just know that basically arrays are probably going to be 99% of your. They can be like 99% of what you use, because arrays are just, they're kind of the best thing that, right? They're easy to get data out, easy to traverse over, and they're fast as well for basically everything. But yeah, so you want to get into computer graphics. Have you tried writing a software rasterizer before? Have you tried OpenGL yet? How much computer graphics do you tried? But that's the thing you want to get into, right? So basically what I recommend, so OpenGL is great and everything, but like it doesn't really teach you like fundamentally like what the hardware does and what it does for you. So I recommend you following like, that's it. I haven't made anything crazy. That's cool. Doesn't really teach you how like the, what the GPU really does for you. So I recommend you like basically implement a renderer in software. It's going to be slow, but you can like render out to like a PNG file to begin with, or if you're feeling a bit more advanced, you can make your own window, open up a window, and then basically copy the image to the screen and do the rendering on the CPU instead. Rasterize your own triangles, and you could basically learn how OpenGL works under the hood, and then you have understanding from then on out like what this abstraction of OpenGL kind of does for you in a way. So I always lose his link. Yes, amazing. So someone who follows the streams suggested that he do the same thing, and he took up to like quite a high standard, and basically implemented his own kind of Vulkan, right? And got like 3D like shading working and everything. So he's basically made his own sort of like vertex shader and pixel shader system, and this is all like rendered on the CPU, and it's a software renderer that just mimics Vulkan, and he's got to sort of learn about pipelines and things, and just rasterizing triangles and pixel shaders and fragment shaders, how they kind of work. Vertex shaders and fragment shaders, how they kind of work. Yeah, I dropped these links. He's got his resources he looked into as well, because I just sent him in a direction and he just went and took it to like level 700. So yeah, I highly recommend taking a look at that and getting some inspiration, because I already teach you a lot about computer graphics. But that's really cool. No worries, so Kenny. Oh yeah, by the way, if you want to hang around in the Discord as well and talk more off stream about anything to do with graphics, you can. There's a Discord here. Feel free to ask any questions or share anything you're working on. So yeah, so we got the error, right? This is good. We ran it. It says structure types do not support default values. Riser struct does not have optional fields. So we go back to that lovely, super lovely .encode file where we have all our data descriptions. So we've got one which is a table, one which is not a table, but it's got these pesky default values. And we just simply remove that and oh. Shoot. I did a silly. I didn't say is table, but it's led me to find out that my generator also doesn't put this in the nice error message or table if we put something invalid in. Cool, so that's great. And there we go. So it's all printed back out. These shouldn't be displaying like this though, mind you, because they don't default to 0. So let's quickly, so let's save as table. We do that one, else. So tables get the optional, if not. Right, so just these struts don't have the equal on it now, whereas these say equals 0, that's the default one. Nice. Cool, so let's just git commit that. We'll just say, add table data type. Wait a minute. Get out of there. I messed something up. We need to say that if it's a structure, it cannot have a table as a field, can it? So parse type. Yes. So here we've got to say, right, hang on a minute. If structure field type kind, let's do that quick, equals type kind structure, then we have to get the other structure and say if gen.struts, the type of the field strut index is table. That's it. So it's a table. Nearly there. If is strut and this is a table, then we would elect error and say a structure cannot have a table. Strut type string has a table, has the table type string, cannot have the table type string in it since a strut is fixed sized only and a table is variable sized. Right. So we'll put the two lovely names in there. So really we should probably have this as a call it table or something. Strut type star table, address of that. Table ident, right, int casted. Right, so we copy paste that, join those lovely lines, and cool. So we could quickly test that one out. Let's go back to that encoder type. Let's try and put this entity 2 inside this structure, and it'll be like, hang on a minute. Let's call it something. Cool. Error strut type level and cannot have table type in it since the strut is fixed sized and table is variable sized. Yeah, spelling's a little bit off, but that's it. Let's correct that. Since a structure is variable sized, or is a variable size, and the table is a variable size. Cool. Right, so let's go ahead and commit that in, and then we'll get onto that. Sort of text writer. So add table data type to encoder system. Neat. All right. So the next plan is, we want to support a text format, because in development, it's just so much nicer having a human readable file format for your data. If it's not too big, right? If it's a bit too big, like an image file, for instance, where you got like millions of entries in an array, you're better off putting that as a binary file. But for most things, it's just going to be, really nice to have it in text format, because you can actually edit the individual values, and if things break, it may be a bit easier to fix it, I guess, but mainly just so you can sort of see the values without a special tool and edit it. Oh, and also in version control, if you're trying to merge someone else's changes, which we don't have this problem yet, but we could do in the future if we have more people working on the project, you can also merge the changes. If someone makes the same change to the same level, for instance, you can merge the changes without a custom merging tool. So yeah, those are the two reasons that I see where we should support a text readable file format. So we're going to get started on that one because it's the easiest, and then we'll do the binary one, which supports all this wonderful bit packing stuff. But yeah. That's cool. Edward J. Finley. Ah, that Pepsi Max mango. Good. So basically, this is going to be some. So I think I don't ever want to start another sort of thing. So this is my source directory where we've got like the game graphics, the game logic, and just some other files. Then we've got the engine folder where it's got the core, it's got the GPU, it's got the OS, it's got the UI. So when it's to do with encoding, I don't know if I should stick it in another file somewhere. Maybe we should move. Yeah, maybe we'll do another one for encoding. So encoding and decoding goes in here, and we have everything in there, right? Text parsing, so that text reader should really go in here. And then we'll also put everything to do with writing out text files and the binary files as well, the serializers for that, and all of the type information that's needed. So it'll all go in here, because the core system won't have to know about it. It's just memory allocators and arrays and stuff like that. GPU might need to know about it at some point. OS will not, and neither will UI probably. But yeah, so these, I think it's be a good place to kind of get it going. We can go ahead and just create a few files. Or I like to have 3 files. You know, for this project, I'm actually doing a lot more files than I usually do. Usually I just have like one big file. But I'm starting to do more files, which I'm not really a big fan of. But I like having... Like, I've seen projects with more files, but yeah. So we're going to have a public header, because I like the separation between like a public internal header, because I like... Maybe I can get rid of the internal header and just have it at the top of the C source file, the forward declarations. But yeah, the internal header is typically quite small. And then we'll do like a .c, right? So let's get in here and go full ham. So I wanna get that text reader that we've got. So this is what we've just been using to do the entity code generator and to do the encoder generator as well. We've just been using this text reader structure. It's just basically a way to help us sort of like skip over text and read text without having to write like a tokenizer. And it's just been a bit quicker to use one of these things and cheese it. So ultimately our text reader and writer for this custom text C-like JSON file might use this because it might be easier. We'll see. So yeah, we're going to take this and so let's go to that new sort of enc.h, so the public header, drop it in there. Nice. We're going to include core/core.h, or maybe it should be engine. Okay. So then we'll go over to the core.c file. We'll go to the bottom here. I'm going to go ahead and nick well. Cool. So that's looking all right. That's moved over, which is cool. But I think it might have broken the the code gen stuff. It's no worries. So I've got to pop into the encoder gen file, and at the top I've got to include these new 2 source files. So encoder, 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 encoder. Now I'll do the same thing quickly for the entity generator. So the same thing again. Encoder, 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 yeah. So those 2 should still work. Great, that works. And then the entity. Yeah. So those both still work, which is legit. And now we can get started on that lovely text. C-like text file writer. So so I don't know what to call it, right? I guess if you guys got any suggestions. So if you know what JSON stands for, right, it's JavaScript object notation, right? I don't even know how to spell that right, but anyway, I think that's right, isn't it? Yeah. So that's what it stands for, right? So what should I call my file? Basically, it's going to be JSON, but with C like syntax instead. So we'll start off with a writer. So should we go with a name like... See, I can't really go CSON because that is then it's like C script, right? Object notation, but maybe it doesn't matter. Right, we just do CSON. If I do without the S, it's called con, which just sounds very mischievous. Sorry for the interruption. Feel free to ignore that. No worries. I've remembered that the glyphs plus matrix is a valid thing if you want to animate your text by glyph. Right, yeah, by each glyph. But that should be a separate shader for a compressed variant. I thought that could store the rotation per text block. But I can figure it out was the best way to do it. And store a translation per glyph instead as an offset. Right. Right. Oh, interesting. Yeah, I do get what you mean. Before in the past, I've done a quick and dirty text render where I did it. There was one text element, and you sort of just render. It was, I wouldn't. It's got its limitations, right? But I did it because it was a bit of fun. Where you render the block, you size up the string of text. You render that, and your glyphs are rendered in here. But it only worked because they were fixed sized, and it was basically a bitmap file, and it was you know that code page for, I forget what the code page number is anyway, the old school ASCII font. And yeah, I could just basically in the pixel shader be like, oh, I'm rendering this pixel. That got made small, isn't it? I'm rendering this pixel, you know, just do the maths, do a division or whatever based on the width of the thing, and you can work out which character you are. But, and then I only needed one transform and one set of vertices for however many glyphs were in a line of text or whatever. It's quite right. Yeah, kind of. Yeah, so I just rendered like tiles basically, I imagine, yeah. Just in one quad of... Oh, did he do it for that as well? Oh, interesting. Yeah, I just rendered one quad and then all the pixels just... Yeah. It's right. Does the job. You're reading the Arduino 3 manual. Cool stuff, a bit confusing. Yeah, it's difficult to sort of understand some of the stuff. Like exactly where the hardware is. We're like, you know, they say the size of this, the VGPRs are this size, whatever's how many of them are in a GP, in a compute unit. Or whatever, yeah. I remember reading it too. Yeah, they got some like, also some instructions in there. And like, you know, that GDS thing. They don't really have access to. And it's like, it's in the hardware. You know. It's just a bit bananas. So I think we'll just stick with CSON. It doesn't have to make too much sense, right? So we'll type def as strut, and we'll call it the CSON writer. We'll do the reader later. Readers take a lot more to do. I don't know if you guys have written many readers and writers for any file formats, but it's way easier just to write a writer because it's less stuff to deal with. Basically, you write that in the way you want to do it, and then that's it. So I think we might get it to... It would just be a text reader under the hood, I think. Sounds about right. Oh no, sorry, that's a text reader. Right. So if it's a writer, then we probably would just like. So we probably just want an output buffer that we write out to, and we could probably like. Yeah. Yeah. So I think you just get a buffer you write out to. So you basically just have like a pointer. So this is the. This is the destination. And then you have a cursor, and you have a capacity. Right. And so now we just go full ham and get this thing written up. Writer, call it W, because there's just no better name for a writer. So here we'll just pass in all those things, right? Where's the destination? So the reason why we're not going to write out to a file is because when you write out to a file anyway, it's going to put it in their own sort of like buffer somewhere else. So I think like if you use like the file API, you know, the C file API, they're just going to write out to their own buffer, and then when you've written so much, they'll flush it out. But it's equally just as good, and maybe it's better sometimes just to write it out to your own piece of memory, because you won't have the interruption of pausing your serializing and then going to write something out to disk and then coming back. So instead you can just write out the whole file into memory, providing you have enough memory, right? And then you simply just flush it all in one go. That's typically better, I think. So yeah, this would be just be the capacity of the buffer that we want to write it out to. So we're not really going to have a deinitializer. It doesn't really make any sense. So now we're going to get to the point where we can start. Yeah. So I think we're going to want to store the type information here, like metadata about the types that we're serializing, but we don't have that information here now. So we're not going to bother. Yeah, we're not really going to bother passing that in yet, but we'll probably pass it in somewhere. So let's just say, well, maybe you can write a strut start and end. Hey there, Wajilla, how's it going? Yeah, especially remember that you can set an amount of cache lines prefetched ahead of time. Fascinating. Oh. Yeah, it does sound interesting. Yeah, like a prefetcher. But yeah, they do it. Yeah, huh. I don't remember seeing that. Been messing around with ideas for my programming language, awesome, and got stuck in a rabbit hole about reading about prefetching queues, etc. Interesting. That definitely sounds like quite the rabbit hole. Think about programming language and then end up down in prefetching keys. Is it going to be like a C-like language type thing? You know, systems programming? Yeah, so when you start a structure, so maybe we can like, so we definitely need like the type the type of the type of the structure. You know, if I can give you an example, it's probably like C compound literals if you're familiar with those. Put the type in there. So we'll say const just. I don't really have to. Screw it. So we'll probably have the name. Well, this might come from It's going to be code gen, so it might be one of these string things. Call string things, maybe. Oh, no, it's going to be a char. Right. So, you want the name? Name of the type. Then, so that would basically just be like, entity, for instance, and then it will open up the bracket, and then the end one is just going to close it. So you don't really need anything here, but we'll probably have some state, which is, since we're not using this directly and it's just going to be code gen, maybe I don't really care about tracking stuff perfectly, right? Yeah, maybe it's okay. So the other thing we want to be able to do is write an integer, or write a uint out. So we want to be able to take it by a value. So you'll need the name of the field, right? Field name. And then also you want to have the value. So to use 64 value since it holds any integer in there. So for instance, you have one called like, I don't know, health or something, right? And then you'll put in, it'll be like equal, and then you'll say like 100. And then if it's a default value, it will omit it, so it won't even be there. So we'll just copy paste that, and we'll do a signed version, right? For all the people who like to have negative numbers. And then we'll have a floating point version as well. So it'll just be with an F. Yeah. So what other type of the other things might we want to do? Like strings as well, maybe. A bit like a core string. So if you print out an int, you sometimes want it to be in like hexadecimal or something, or maybe octal, I don't know, but Boolean. Well, Well, you could take in like a radix or something. We could just do an enum. Probably the better way. Int format. So it's probably going to be pretty printed. So we're going to want to have an identifier, an indent. My brain today. So we want to maintain the indentation. So when we do these fields, it will go down to the next one and tab in correctly. I don't really want to support something that's not pretty printed, because the whole point of this human readable format is that it's human readable. So having anything that's condensed is the binary format, right? So yeah, then we won't have many if statements. So you'll have like a C-son int format, and you'd be like decimal or hexadecimal. Maybe we support octal. I've not really used octal, to be fair, besides doing something with the file API in Linux. So I reckon that ought to be good enough. It could have been a Boolean, but Booleans are not readable, You see false in the code or true, and it's like, what is this? So you obviously want that for the signed one as well. So tables and struts can just use the same API here. You know, there are arrays of things that we've got to do as well. Right, we have an array. So an array start, array end. I've got to think about how I want arrays to look. So imagine if you have like a level. You have your entities. Yeah, maybe I have that dot syntax as well, like it does in C, right? So you say entities. This is an array. C would do this, right? So maybe if we see this without these brackets, then it must be an array, right? And I think that's a good way of doing it. It's just specific for me, so it doesn't really have to matter so much. So my concern is we might need some extra state. So start array, end array. It's good. That's the idea. Yeah, C like language because I want to know how C works better, statically type and compiled system language. Awesome. Yeah, sounds pretty fun. Yeah, it's good to do a little custom thing rather than the real deal sometimes. That's great. The SOP instruction, set instruction prefetch distance. I thought SOP was a class of instructions. This is the 2 one, but let me have a see what's in there. Yeah, okay, SOP is a class of instructions, but yeah, it's in there, it's amongst there, isn't it? Instruction. Oh, they don't have wait. Yeah, okay, they have prefetch. Yes, they have a prefetch, but they don't have prefetch distance, maybe? The prefetch distance might be an RDNA3 thing. So yeah, so this one you can control set in 1, 2, or 3 lines. Interesting. And then you have RDNA3. Let's see what the difference with this one is. Set instruction prefetch. Maybe it's the same thing, they've just named it better. Oh, it's the same thing. Right, fair play. If only they gave us proper access to GPUs, you know. Another silly abstraction that we have. Just man, fingers crossed to get it off the ground. Thought about writing a renderer. That was difficult, most difficult thing I was tackling, but this is way more involved. Makes it more fun though. Makes me appreciate C a lot more. Awesome. I don't know, like, I guess like yeah, running a 2D renderer isn't that bad. Versus a compiler. Compiler's a lot more involved, that's for sure. But like a full-on like 3D renderer with all like the latest and greatest technology, that's definitely more complex than a compiler. But yeah, well, it's complex in different ways, right? Renderer is complex with maths and like kind of like physics, whereas like a compiler is complex because you've just written parsing code for like a kind of a language. But yeah. But that's cool. Yeah, it'd be good. I remember when I wrote, I wanted to understand a little bit more about x86 and ARM assembly. So I basically wrote a hybrid architecture and I wrote a simulator for it. So I was reading the docs for one, reading the docs for another, and I was like, And it worked out kind of alright. Now, it was a good learning exercise, that's for sure. Not really practical in any other reason. Yeah. It's a bit bizarre. Like they've got their compiler. I don't know if you remember me trying to see how many VGPRs my shader was using. And I was like, you know what, I could chuck it through their shader compiler. It's open source, right? And I download it and I run it and it crashes. I'm like, ah. Like I get it to try. Because how cool would that be if you could just take your SPIR-V file and chuck it through their compiler and get a binary out and then use disassembly tools on it or whatever and just see what, you know, or like, you know, run a compiler and then like give it to Vulkan, but you know, it's a strange world. Yeah, Phil, you never approached GPU stuff before. I always tackled the software. Oh, sorry, no. I always stuck to software rendering. Did your CSPV compiler? I think it was a previous project. Yes, correct. Very true. That's cool. Software rendering. That's great. It sounded like, yeah, you kind of went the right direction there. For me, I didn't know software rendering was a thing you could do before I learned OpenGL the hard way or whatever. Um, but yeah, the one thing I have a problem with this is you might have to know if you're inside an array or inside a structure, because an array is just going to put down. Oh, no, you don't. So this would be like writer. Right, hang on a minute. So field name. See, another thing that I supported in my C like JSON was having enums for arrays. So you could be like, you know, whatever this was like entity player, for instance. Terrible example. But it would be used the array designated initializers. And it was really neat for when I was doing like some tile map thing. I could, yeah, it was proper cool actually. It also added some extra syntax as well, which is specialized for the game I was doing. But I wonder if any of this would be maybe useful or not. Because, so, you know, we wouldn't need two separate functions if we wouldn't need two separate functions if we knew we were. So Boolean is array, right? So it starts off as false, meaning a structure. Well, it doesn't matter because you'll start a strut anyway. Then when you start and then end, but then when you end, where was you at? You've got to have a stack of that. So you'll have like a stack of those, but you could just encode it in like a 64-bit int, right? So basically you just use the bits, and we're not going to have an indentation over 64, right? That's the max indentation. And that could do it. So you start it, yeah, that'd be cool. So when you put a field name in there, say if we wanted to support this, like, you can have an array, but then it'll also be like an enum backed array. I could support that in the future, where I would pass in a name and it would wrap it in these brackets. That'd be pretty cool. And we'll pass in null. If not, a null will not do anything. That would be pretty cool. So my concern is though that actually these should all take a field name in. Well, those two should, because obviously when you start a strat or start an array, they need a field name except for the root one. The root one does not need a field name. What else do we need to do? I think this is basically it. We could just get going on it. Shouldn't be too hard. Just go to Encoder, go to the bottom, drop those boys there. Grab the other. Did we not do a header? Oh, we did. So yank that. Put that in there. Right. Oh yeah, we probably want to weigh. Nah. Maybe we have a way to sort of like flush it out to disk as well, built into this thing, but I'm kind of unsure about that at the moment. Cool. All right. So I think we want to have some sort of like internal methods or functions, whatever you want to call them, where we basically say, you know, I'd like to be able to you know, should we have a like, so if we use that sort of printf formatting, it actually makes it slower. So we should really try to avoid that where possible and just simply write the strings on ourselves. So yeah, we should definitely have ways of like pushing on strings though. You know, maybe I have there's the internal one. All right, let's drop that in there. So we want to have like a, let's write them out here first. So CSON writer. So I want to be able to probably like advance or like so in most cases we just want to push on like a string, maybe bump on a space, right? In places. Yeah, just push on strings basically. So we want to say like, you know, so I've already got this string on there, but that takes in a field. So we'll probably want to just say like push string CSON writer W. We'll probably use our own size string thing. And so with this, we can basically just say if W, or maybe a. So if we overflow the buffer that's provided, do we want to assert or just do nothing? And then at the end, we can just check, oh, did it overflow? Right. I don't think. I think we should just allocate enough space when we finally allocate like so many megabytes, and that's all you would ever need. I don't think our files get, but they could do, right? So in that case, maybe like if we don't crash and then we return it back up, I don't know if I'm going to gracefully handle it anyway. Like what am I going to do? Try again, right? Allocate another buffer and try again, but I don't want to try and have those reallocation schemes. Hmm. Yeah, we'll just assert it for now. Came up with a new name, CIS, Component Instance Structure. +1 for nerdiness if you know what CIS stands for in Star Wars. Ah, crap. Hmm. No, I can't get it. No. Maybe remind me. I'll probably remember if you say it. Component instance structure. Okay, nice. Oh, we're seeing right now. Damn straight we are. This is the way. Yeah. Custom file format. Hey, Sockham. -1 for nerdness. No. Confederacy of Independent Systems. Right. See, that first word I was thinking something like that, where it's like a council or something like that. You know. But yeah, Confederacy. Got it. Man, I miss Star Wars. I remember I was watching through the Clone Wars for the first time. That was good time, but I went through it all. That's right. It means I'm not paying any more money to Disney. That's a good thing. Course, W. Writer. Hey, why didn't this include the Right, so what I'd like to do is say if cursor plus string size, yep, take, oh no, so that's greater than W capacity, so make sure it's less than or equal to, and we'll just simply say CSON writer overflowed the allocated buffer. Of this many bytes. Sad face. Cool. So yeah, we'll just, get the insert index, W cursor. Oh no, we don't need the insert index, just cursor in it. So the W cursor plus equals string dot size, and off we go. So we'll do just do memcopy, I guess, memcopy string, W destination plus W cursor, string dot data, string dot size. Now memcopy is probably overkill for a lot of the strings that we're going to pass in, but hey. Whatever. Right. W destination, W cursor 0, W capacity, W indent 0, W array, and then bit says 0. Okay, good. So, I think a lot of the stuff is just going to use this push string thing. So let's go back to that header file. Drop it in. So it's just an example of the file that we're writing out. So if it's, so we want to know if we're in a structure or if we're in an array, I guess. So we could say if we have no indent, just don't, better be null or something. Yeah, I guess we could do an assert. Oh, it's GM, isn't it? Oh no. Window top T, C, and B. That's what I was missing. Oh. Yeah. Anyway, cool. Right, so I think I'll put an assert in here as well. It's kind of good if we assert these things. So if the indent better not be equal to 0, or field name. So if it's 0, then field name better be null. So basically we cannot have a field name. We cannot have a field name for the roots. Types. So I'm thinking that we basically have, at the root, we only have two. One is going to be the metadata and the other one is going to be whatever the root type is down there. Or it could just be metadata, right? You like metadata, you name it. Metadata. Seems a bit weird. Yeah, I'm just going to make it not have it. Right, so you're always going to bump the indent by 1, but you're always going to encode inside that is array thing. So we're going to remove the bit which is at 1 shift left. W indent. Yeah, so we always have to take 1 when we check it. Then at the end we're just gonna take the indent and, well, we still haven't finished here. So we probably need another sort of internal function which basically writes out the, I could call it write maybe instead, write string, write indent, as this will write all the indentation stuff. So when you start a, so we'll probably just use tabs, right? Just do a for loop, and we'll push a tab on every time. Maybe we can have a push char as well, because that might be useful. Yeah, whatever. So bump 1, bump 1, cursor, equal character, then bump by 1. Neat. Yeah. Cool. So we just do a nice for range, index 0, indent. So you got no indent, it doesn't obviously iterate and do anything. And then we're just going to do a CSON right char, but Yeah, it would really be better just to bump 4 and write it in. Maybe that's another thing we can support as well. So it's just a way to sort of maybe it's just a way to sort of like write and you get back the right pointer. Something like this. So you have like an amount. You bump it. Cool. And you get the pointer, so that'll be DST destination plus cursor, and we'll just return the DST like that. So we've got these 3 different convenience functions, I guess. So here we want a destination, and we're just going to write out indent worth of those. Go over every one of those, and then just write in there a tab. Nice. That's the indenter, and we can simply just, you know, when we're writing a field, every time we write a field, we have to indent it. Run a field, we indent. Do some extra build like stuff here. Probably do a CSON writer write string. And the string is going to be, we might have a C string version as well. So it will automatically do the string length. Which will just get compiled out. W string writer write string W string length string. That'd be right in it. Yeah, so this would just be the convenience version. So we can do stuff like, well, we want to, after the indent, we want to put the field name. So we have a field name. Can I increase my face? What's wrong with my face? I should probably be moving like over here though. Be better. Outside the way of the code. Yeah, I got a new webcam, so things should be looking much more high quality. Because the other one broke and it was 720p. This one is 1080p, but it does support up to 4K. But yeah. Yeah, put it right in the middle. And you can't see anything. Hey Lupo, welcome. How you doing, sir? Can't seem to get the shader reading working correctly. No. What do you mean by shader reading? Do you mean like compiling the pipelines? So really we should error of like really we should say put the assert in here. We'll move it. Right, so this one wants to print out the name of the strut. So we'll put in the field name. You know, maybe these should be. Did a string length every time on that. It's just a bit dumb. Yeah, right, we're changing it. We're code genning this anyway, these things. What's going to call this writer. So field name. Yeah, everything's none of the C strings. C strings are annoying. But we'll keep the C string convenience function because when we're doing hard-coded symbols and that, it might be easier. All right, that's cool. So we write out the field name, and then we also want to write out characters beforehand, right? Because we're basically writing this. So write that, this, then that. So we got to do char paren close paren, and then we would like. Oh wait! Sorry, this is field name. My mistake. Field name should probably be another function that we call then. Crap. Whoopsie. We should probably have another convenience function again, specifically for writing out a field name. Call string. Name of the field. So to write the name of the field, we probably would like just write string followed by a C string, which will contain a space equal and a Oh, we also need a dot as well to come beforehand. So put on a char, please. And a dot. Right, I think that's good. Why is this one moaning? Oh yeah, you gotta do like wrap it in a core string. Alright, I've already got one of them. There's the string length inside that macro. Cool, so this will be super handy for all those different, when writing different fields. So we're gonna instead, if you have a field name, write out a field name. So W and then the field name. Now this code actually needs to be moved down here and needs to be using the name of the data type instead. So it should really be called type name because we've got two things with like a name in there. Right, it's just a bit weird. Right. Yes, so these are assertions. When we start a structure, we should put an assert to say that you have no indent. Wait. Yeah, that you have indent. And this one says no indent. So we have a field. We must have a field name for non-root types. We must have a field name. Wait. Is that the same thing? So you would like to say yeah. we must not have a field name. We must have a field name for root types. This one we cannot. So this is when you've not passed in a field name, but you're not the root type. Field names must be provided for all non-root types. There we go. Cool. So this we put in the type name. So we do type name. That'll be a string, C string with a bit of a space. Open bracket. Do we want to do any new lines here? So I would have done some indentation maybe. Where's the indentation at? I think we haven't used that one yet. Well, if you're in a field, right, it should automatically do the indent as well, to be fair. I don't know. Yeah, so when you write the field, it should always do the indenting code. Then we write out this, that, then we do a new line, and then you can go and do your fields and that with the next set of function calls, really. And this one is just saying remove the bit out of that indent to say that it is structure and not an array. So we can write correctly for, I forget what it is. Yeah, for these things, these field names, isn't it? Field name. So rather than field name being a dot, it could also be a sort of designated initializer for arrays, basically. Right, so we need to sort that out as well. Yeah, sounds like you've not read the file in properly. Yeah, spivvy this, give that a go. Yeah, it seems like you might be reading the file incorrectly into your program. Make sure you're reading the file properly. And check the first 4 bytes. Spivvy spec. Sorry for this blinding screen. So there's a magic number. If you see this, so print the first 4 bytes out as hex, and see if you see this number or this number. Yeah, it will be that number. The endianness could be swapped, but you'll be on a little endian machine, so it should be fine. And if you don't see that number, then you've not read in your file correctly. I'll drop it in the chat, because that's the magic number for the file. So here we're trying to say, like, are we in an array? One shift left. Indent, and we're checking that. Against W is an array bit set. See, I was thinking, like, if we have a way to indent and unindent, we need to make sure if they're not go over 64 or something, isn't it? And right, so if it's an array, we do something else. If not, it's a structure, and we print out with a dot the name, then an equal. The equal can really go here. And then this should really be surrounded with array stuff like that. Cool. With a bit of a space. Oh, it's done it there. Good. Yeah, so when we start a structure and we increase the indent, we should really do a core assert. Maybe it should be a function, but we've only got 2 of them. Increment W indent is less than 60. 64, I guess. Yeah. You know, writer has indented more than 64 times. And if we reach that and we really need it, I doubt we will, we'll just add 2 bit sets. So here we want to say like has decremented more than incremented, and I guess that'll catch some invalid code as well, which would be nice. More than it has incremented. Or than it has indented. Yeah. Cool, so we can call a function W deck. Yeah, so I think that's a structure sorted out, right? So an array is probably kind of similar. What's this complaining about? Size we want to be looking at. Okay. Right. Yeah, first 4 bytes. Bytes to the file, yeah. So when we start an array, we don't really have any type name or anything to go in, because the arrays are going to be like, it'd be like this, right? You put the field name in, put the equal down, and then just open curly. So they're not going to have the type name before, they're not going to be compound literal, like, right? So that's going to be quite simple. We just basically push on a curly, and then we OR on the bit in the bit set at that indent to say that this one is an array, so when it next puts down a field name, it can do it properly. Which would be pretty cool. So when you end an array, it is simply just gonna decrement the indent. Okay, so now we're just left with these guys. So it's very similar code. I think we might want to support optional names, do we? Only if it's an array, you see. So I think inside here, we can say if it's an array, but if it's a strut. So if it's an array, if name.size equals 0, will return. So it'll still indent. Yeah, that's the thing. Sometimes you might not want to do an array on a new line of an element every time. But we'll start off with that for now, and we'll edit it. Because sometimes if the array is small enough, you might want to stick it all on one line. But yeah. Whereas here you want the assert, where a structure field always wants a name. So struct field requires a field name. Yeah. So that'll be pretty neat. We should just be able to pass it in without the conditionals in here now. So that'll put the equal sign in there. And then we should be able to put the value on. So we do have Yeah, we don't really have our own functions for this at the moment, so I'm just going to use the C standard library probably. C standard int to string. I forget if they support this in the standard or not. I know there's the A to I function, or I to A, whatever you call it. But that's not standard, I don't think. Yeah, you're better off using printf, isn't it? I guess we'll just printf into it, you know. Fine. Yeah, take that. Yeah. Basically, I just put like, if you put like from or on viewers or whatever, it just catch it, and they don't put any UTF-8 strings in there. You might mention, but how will you represent F32 in text format in hex? Oh no, it'll be in so it's all just gonna be as a string. So you see all this bit packing stuff that we're doing. Yeah, that's not going to be supported in the text format. This is purely just for the binary format. So in the text format, it's purely going to be human readable. So whatever the value is. Yeah, that might be problematic because you will get different precision when you save and load out from text files. But yeah, compared from the text file compared to the binary file. But yeah, I think that is, we'll just print it as a string. So I print it as a floating point literal. Yeah. So I guess we've got to use printf. It kind of sucks. It's not the fastest thing. You know, we should really write our own, but I cannot be bothered. I'd rather just get it done. Well, you would just divide by 10. The problem is just the errors in doing so. And you'll count the number of digits to pre-allocate it. So for now, we're just going to do printf. So the problem is printf is also going to put the null terminator down, but it should be okay. Yes, you passed in null 0, and then it will just give you a size back. ZU, then the number, the value. Now you'll get back the number of the size that we need. So now we can say write, we'll pass in a size which we're trying to bump. although we want to bump allocate, get a destination pointer, and then we simply sn printf into that, and really we should +1 it. So we should just say it's got enough capacity. So we should just use sprintf. And it will null terminate it, but it doesn't matter for us. Yep. Cool. So that just saves a bunch of time. You know, it's technically going to be slower, but if we need a faster version, we'll just change it, right? So same thing for decimal. Well, signed numbers. Cool. Wait. We've got to worry about like commas and things, but let's just get these in here and we'll worry about that in a sec. Float, bit of F. So, Which camera are you using to stream the stuff? It's specifically troublesome to print out float 32s, F64s, even more troublesome. Or are you talking about like the precision and things? Because I was just thinking about that. Like the strings might be quite long, and I think maybe it will round things, wouldn't it? Yeah, it should be okay. I don't think it'll be a particular concern, maybe. But please tell me if I am underestimating how bad it would be. There we go. Awesome widget. Fair play. Very cool. So I've read it now, and now I've messed up something in the create info. That's cool. Well, at least you found where it is. That's great. And you can't just multiply it by 10 and then it prints and print digits. Right. What language are you going to use? Well, I'm still using C. Yeah, just using C. That's what we're doing. Yeah, the Encoder C310. That's the camera I'm using. I recently just got it. It does work on Linux, but you've got to have a Windows box to configure the camera and then switch it to Linux, and then don't touch any settings. If not, it will not work. It will reset it to something. Maybe there's ways to configure in Linux, but I couldn't do it quick enough. But yeah, it's a good camera though. It does look kind of nice. 1080p, 60 FPS, 4K, 30 FPS. But we obviously just do a 1080p one, and I shrink it down a bit. But yeah, it's pretty cool. It also has ways of supporting, like when you use the software on Windows, you can like crop the feed and sort of move it around within the cropped area. So I did that, and I've got it on my green screen behind. Yeah. It's pretty cool. Yeah, so floating point maybe, because it'll like round and stuff, isn't it? It should be okay for now. I guess if I get any problems, maybe. Yeah, see, let's go. Yeah, exactly. It's all just C, you know. None of this CPP. None of this Rust. None of this Zig. None of this Jai or whatever. You know, just C. Probably offended someone just then. Jokes. Strings. We'll just write those out using that. Yeah, using those two convenience functions. So it's kind of basically there now, but we're just missing writing out like the comma, or doing a new line basically when you write out field. So we probably want to say like field end or something like this, and it will do a comma and new line, which would be interesting. So maybe we could say right field start, right field end, and it puts the name in there. That'd be interesting. Yeah, because the problem is, right, for arrays. For arrays, you might have a bunch of integer values or whatever, and it might, or floats, these end up looking like, I don't know. Man, had the wrong key pressed. So sometimes it might be good to just display it all on one line because it's only a small array, but then another array should really break down into multiple lines. Because they're more complex types. So maybe if the type of the array is just a primitive type, just do an array that's all in line. If not, do some new lines. Yeah, maybe we should support that. We'll try it after, I think. So right field end. So field end will put out a little bit of a C string. So it'd be a comma and a new line. And I think that's it, to be fair. But yeah, we're always gonna make it a little bit more complex when it comes to that other thing we wanted to do. So this should probably be renamed to start, like that. Nice. And now we just drop these boys and girls down here. So we drop on every one of these because this just writes out a field. Array end, when you end an array, you want to do one of them as well. Wait. When you end the array, you need to write the char. We've not been writing the chars. Yeah, then it does a comma and then a new line. Yep. Cool. Yeah, I think that's all right. So I think we've got like a good first version now, so we could just give it a go and see what happens. So we could try it in our in my OS API. Have I got like a file? Well, I haven't got a file write all yet, so maybe we should implement that. Technically, it's const, right? Yeah, so we just find the implementation for that. I think it's in Linux and one in Windows too. Right, I've just done it using the C file API. Bit dumb. In the past, I've definitely done it with the native APIs. I've got an unbuffered API in different places. But yeah, sometimes we do things for the sake of just getting stuff done, Right, binary, because on Windows, well, this is actually only on Linux, but on Windows, it will start trying to take your new lines and turn them into carriage return new lines. Yeah, Windows. There's plenty of algorithms for float printing, but the precise one is super slow for a float 64 and manageable for float 32. I only print float 32 in my codebase. You can see an example of a fast but not as precise algorithm in STV sprintf. Right, fair play. Yeah. Yeah, my main concern is that I want the file to be human readable, so I think I need, yeah, maybe I do need a better formatter than the standard library one. We'll see how it works out. Yeah, because the problem is I'm going to be writing out damn model file formats, isn't it? But they're all going to be float 32s anyway, so maybe we should not really worry about float 64 encoding type for text files. I don't think I'm going to be using a double for anything. Oh, you didn't use memcopy, so I only sent the first 4 bytes. Right. They're somewhat strict with floats. Oh, okay. Well, yeah, hopefully it seems alright. Yeah, we'll give it a go for now, I guess. But I'm writing a lot of my models out in it. So my concern might be the center position is in signed norm space, so -1 to 1. So I think it might just tack off the end of it and round it up, because it's like, oh, it's only a small number, it's negligible, but it won't be negligible. So maybe what we need to do is not use floating point in that case and actually store it as an integer between and then that should be good enough. Yeah, so I think when we're using floats, we're just storing them as ints if we need it to be precise. No ftel, just a bit of fwrite. Bit of a pointer. That's data in it. Data. Size. If write size not equal to size, then return false. We always want to close it from here anyway. So I guess we're just gonna do a lovely bit of return. Long. What's wrong with my longs? Oh. I think that's alright. Then on Windows, I've got to do the same thing, but yeah. Let's just quickly go over to OS Windows. So right now, it just is a copy and paste of the exact same code. The thing that we obviously want to do is use the native APIs and just, because then it would be unbuffered, as it's called. So just does a system call and writes it all out, or do a few system calls probably. Hopefully the minimal amount. Right, so let's get this thing tested out and see how it goes. We have decided to not really handle the format here. So let's look at that quickly. Or maybe we switch on the format, to be honest. Format. Switch. Format. Case. Decimal. format equal z %ze break hexadecimal. Spelled wrong, didn't I? It's hexa, isn't it? Right, hexadecimal here. Whoopsie. Right, hexadecimal, so that'll be with an x instead, and we also want to prefix it with 0x, so we get it actually resembling a integer, a hexadecimal integer type. I'm just gonna get this sorted out. All right. This be with a oh yeah, yes, this would be with a D instead. There. Cool. Nice. Yes, let's get this thing tested out, have a bit of fun. So we could do it at the start of the game, or we could do it in the encoder thing. The encoder thing's a little bit easier to trigger, and you know. So we'll do it in the encoder generator. Just kind of a bit of a play. I don't know. We got anything we want to try and encode? We could, for a bit of fun, try and encode the metadata for some reason. We'll hard code it out or something. Yeah, let's go over all the structures and just write out like some of these things. We'll do like the structure types, right? We'll just encode the structure types out for a bit of fun. So basically we'll have the C object notation writer, call it W, and then we'll initialize it, so we'll get the buffer. So this is the temporary buffer that it'll live in. And let's just say it's gonna have 1 megabyte. A bit too much. You know, 64K ought to be good enough. So then we'll stick in like, yeah, sorry. So we do CSON writer in it, and we're just gonna pass in a pointer to the writer. We've got CSON buffer, and then we're always gonna do size of CSON buffer. So that'll just instantiate the writer that we've just been making. Right, this one in it will also do round as well. We'll snap to the closest one divided by int boundary, right? Yeah, we'll round. That's cool. But it would be a precision that I've determined at least. So that'll be good enough. Like, it is going to snap anyway, because is it going to snap? I forget. Your stuff me too depends on the paper. Very, yeah, gatekeeping. That is true. Yeah, so with those like research papers and things, like, yeah, some of them are like quite alright to read through. Others require you sort of go and read the previous papers that it references, right? And understand those, and then you basically, there's a whole bunch of papers you have to keep reading. It's like the problem with dependencies, right? You'll read the previous papers, and you'll read the previous papers of those. And And yeah, the maths is, if you don't have like a maths background from school, like I don't, they're definitely a little bit hard to follow sometimes. But yeah, there are lots of like videos out on YouTube for a lot of things these days, so you can go there. There's also lots of blogs on the internet. They're quite difficult to find, some of them though. There's very specific language you have to use to find them. So sometimes it is a case of really Googling around, or even just asking people online, or people you know, if you know anyone who does graphics programming, because I'm sure they would have come across those as well. I'm not sure if you should fear about storing as text floats, as you could always check if the value is badly rounded. Right. Wait, okay. But I'm not sure if you should fear storing it as text floats. You could always check the value that you've written is badly rounded, but then is not badly rounded. And is bit very big or very small values. Right, so it happen to big or small values. Fair play. Yeah, so that's cool. Yeah. Yeah, I think it's mainly gonna be a problem for my signed norm values. Yeah, I'll probably use integers at that point. So I'll bound it between like, I don't know, 64,000 or something, 0 to 64,000, you know, and that should be good enough. That'd be quite easy, I reckon. So I think we want to start off by writing out, like, should we start a structure or something like that? So we'll start a structure and we'll say, so we're not going to have to write any of this code out. We're going to code generate this code in the future. So we're just testing out the API for now. So the string we're going to write in is, so we're not going to pass in a field name actually here. So we'll do a null, 0, 0. And then the type name, we'll call it, you know, good old test. Right. So I guess we could start there, right? Just write out that and test it out and see what happens. So the final thing we would like to do is do an OS file write all. We've just written this one. Write all. We're going to write it out to a test.cson. Bit of CSON buffer. Now, the thing that you wrote out, there's a certain size. You know, maybe we should have a way actually inside this writer structure to just say, you know what, flush, and it will just flush it out to disk. So you just say, hey, I want it in this path here, right? And maybe that is the way to go, since that's how you're going to use it most of the time. Well, yeah, probably is how I use it most of the time. So we'll just use that sort of OS. Just going to include OS quickly. OS file writes all. W. Hang on a minute. Let's path, isn't it? Path w date destination w cursor, and we'll just return that. I think that's right. Yeah, path data size. Cool. So that's pretty neat. Then we should just be able to say CSON writer flash, and we simply write it out to this test.cson file. So we simply just copy this for loop and stick it here, and we'll comment it out quickly by probably just putting a break in there. Or we could just do something like this, and that'll do it. Passing the writer, we forgot about that one. Short version, problem with text floats is most likely to occur with very small big values. Small values, as you see, is probably a good idea because you'll get equal gaps between values, which is nice. Yeah, it's kind of like a fixed point in a way. Very true. Right, when you take pointers. Okay, so let's give this thing a go, see what happens. Right, so we run the encoder generator. It's going to clang compile it and then just run the executable that it compiles. And it fails. Do we not pragma once the header file? And then also the internal one. Yeah, it's not up, is it? .c file. So the internal ones that I made, so these boys and girls. So this needs to include the encoder.h file. Nice. So just got to find this macro again and just delete it. Oh. Cool. That's great. Right. So let's see why this doesn't work. OS.h don't exist. Okay. So it's in engine, in a game without an engine project. os.h. All right, give that a launch. Here we go. Boom. So something happened. Hopefully we didn't destroy the whole computer. You know, writing stuff to disk is dangerous. You know. And where the hell we ran it. Oh, here it is. Test.cson. Let's get the boy open. So, yeah, it has got a bit of a trailing comma though. That's okay. Doesn't matter. So I think we'll have one root type. Or we might have two root types. Now they'll just be stored next to each other. One would be metadata and the other one would be the actual type. So the type metadata will be stored in here, and then we'll have the actual type, the root type here. And I think that'll just be good enough. Technically you could wrap it in more brackets and do proper field names, but I think this is reasonable. What did it do? Where's the if statement? What do you mean if statement? So we've just made, hey Kappa, welcome, welcome. So we've just made our own sort of JSON, but for C, so it's just C like JSON basically. So yeah, we've just literally just encoded out our first file. So we're just going to test it out by kind of encoding the type information that we've parsed up for our custom encoder data description file, which is again based on C, but it's got some few other things about it. Like it's got ways of expressing how I want to pack data down into 8 bits, and it's within a range. And it's also got ways of saying how I want to. You got a thing called a structure and a thing called a table, where tables can have optional types. So it's a bit like flat buffers, the way that one works. But it will be encoded differently to flat buffers. Yeah, I've not done. Yeah, so it's just a data description form. So we've just encoded out a data. It's just data. Yeah, it's just the data, no if statements or anything. So it's like a config file would be printed out. So here we're just going to say, you know what? So we'll start another structure. This one is going to be called strut type because we're just going to serialize this out as a bit of a test. So really, this should probably be an array. Okay, so in here, we'll encode, let's go to the strut type and get all the things. It's got a bunch of fields. So should we could do a line and a column, the ident, and then the fields, right? We could do that. So let's say writer uint. So write our uint. We're going to write out the core string C line. The value is going to be s location.line, and the format CSON in format decimal. We'll do column in hexadecimal for a bit of fun. Then we also would like to print out the identifier. So that'd be ident like that, and string. Cool. And then we'll also print out the number of fields that it has, fields count. That'd be fields count. And then we'll also print out the actual array. So we'll do an array of, hang on a minute. We'll do an array of fields. So we be something like this for loop here. It's all right. Drop that in, and we'll go over the fields. So we'll basically just print out the data type. And so how does the print format do it again? So context-aware printing, $ field, data type. It uses type string to get a type string. So we'll nick that. So we can get things like data type. So so type yep, there's that one. Then we want to obviously print out the identifier as well. So do another one of them. Bear in mind, this should probably just be using SF, structure field. This be structure field ident. I think that'll be good enough. We need to begin structure and end structure. I did forget that one. So effectively, when we code generate our text encoding stuff, it's basically going to produce stuff like this, right? But it's not. This will probably be wrapped in another function somewhere called like structure field CSON or something like that, right? And then that's what we use to write it out. CSON writer, and then it'll just like write it out using CSON. That's pretty cool. Field. Right, so I think that's pretty legit. Let's see what happens, see if it blows up the computer. Yeah. It's like C script object notation, but we're not using C script obviously, but it'd be weird if I called it con. Right, so CSON is the way. So I think that's good enough. Hopefully we don't overwrite my whole operating system accidentally because I'm writing files. I'm always scared of that stuff. Yeah, I think the worst worries is when you start manipulating path strings. It's like, oh my days. Right, so right at UN, what have I done? Yeah, you want decimal, not decimal, innit? One does not simply run out of memory. Right, so my... right. So the problem is the callback for the assertions have not been... They assert themselves and ends up just being recursive. Yeah, it's trying to use the game out of memory handler. What have I done for that? Right, uses message box. Does that use like a custom allocator, which is not initialized? Yeah, that's all right. It's all right. Doesn't matter that much. But anyway, what's the actual problem? So w indent, we must not have a field name for root types. Two 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 two. No, 1156. It's saying there, but really it's probably here. Oh. Wait. Yeah, you shouldn't have a field name. This must be a field name. Right, let's try that out, see what happens. And we've got another problem. No worries. That one is saying field names must be provided for all non-root types. So what would I do here? Into it, so 116 0. Probably that one. So we did provide the field name, and because we provided the field name, hang on a minute, field start, structure, No, that's not, is it? It's 202 where the problem is. Oh, structure start. Right, it's a different one. So if we have, hang on a minute, what's this? Oh yeah. We need to put a field name in here. So the field name is going to be like core string. What did that? Core string C. Let's call it structure types, strut types. And then this one is going to be called fields down here. Cool. Right, let's give that a go, see what happens. Seems alright apparently, so let's hop into the CSON file. And we have nothing by looks of it, but that's because we need to refresh it. So we're going to say reload. Reload. Boom. It's kind of looking good. We've failed a bit on the new lines. We have also failed a bit on the... so set the language to C. So we get a little bit of the syntax stuff. There's quite a few problems actually, but it's kind of getting there. These probably need to be wrapped in... There's so many little things, but let's just start with the new lines and we'll get everything else done. So after you start an array, we need a new line. And then after you start a structure, we also need... No, we've got the new line on the strut. That's fine, but not on the array. And the indentation is too many. So the array, when you start the array, probably would be better to do it separately or manually, to be honest, because this one calls memcopy, but oh well. Memcopy is not really designed for doing small stuff. But yeah, we need the new line in there. And then yeah, okay, cool. Right. So next problem was the fact that there was a what was it again? New line. New lines. The indent is one too many. So when it indents, when we write some indent, we should actually be saying if w indent equals 0, return early, do nothing. Well, we shouldn't really be indenting. So maybe we'll say, hang on a minute. So this would be a good case to be like a structure or because it should only call indent if no, it calls it on field start. And field start gets called on arrays, doesn't it? That's alright, yeah. So indent not equals 0, please. So write has not an array or strut has not been started. And then that way we can do a take one. And then it would be writing the right amount. Yep. So let's give that a go, see where we get at. And then we'll just keep ticking off the errors. So do a little bit of a refresh, a reload. Oh. There we go. So that's a bit better. So actually, we don't need to take one. I was wrong about that apparently. Take one is actually wrong. So that was wrong. It's also not indenting the end of the arrays or structures. So let's get back to the indent code. Delete that line. Delete the take ones. Yeah, so we've got another thing with when we end the structure of the array, we actually need, there should be an indent here. CSON writer indent or write indent. Bit of W like that, very good. And then the array also needs it as well. Right, so give that a go and see what the next set of problems are. So CSON, bit of reloading. Cool, so we're we are improving, right? So we've got this, entity, and because at line 9 that looks good. This is hexadecimal as we requested. This is a string which is not put out as a string, so we should sort that out. So strings, when you say string, so it's here, we should actually push on 2 characters. For the string literals. So regenerate, switch over to CSON, and then we'll do the reload again. Right, so now everything has basically become a string there, and that's fine. They are strings. Nothing wrong about that. We don't have the length encoded in here. The length is kind of nice when we decode it, but it's also a bit fiddly if we want to edit it because it's a human readable format, isn't it? So we're not going to encode the length in these files. This is all looking correct. We've got, wait a minute. Oh yeah. So this entity type that we've read up has a coordinate of that, health of that, right? That's the data type there. Yep, it's looking all right. And then if we go into the next one, this is where it's failed. It's actually failed to, it's treating it like an array, right? Like it's a designated initializer for an array. So something buggered up when we ended. Also, why is that called test? That should be called fields. Why put fields in there? What happened? Array start fields. Yeah, it's fine. Yeah, let's go back to the CSON thing. So, right, that's to do with that bit set or something. I don't know what's going on. So when it starts up this new structure type, something to do with the indent. What's up with the indent? Do we do the decrement in places? Right, structure end, yep. Are these brackets making sense? Yeah, which means we've done the start and end correctly. But these ones, when they start and end, went okay. So this was an array, though. So it's as if, yeah, something to do with when we used an array here. Wait, and why is it saying dot fields everywhere? That's incredibly wrong. This does need to be a nothing. And this is why we're making a code generator, because this is just a bit too fiddly to do manually every time. So go back to that CSON thing. Yeah, so I think it's to do with like that is array bit set. Yeah, something's a bit weird. So go back to the writer code. So when we start an array, we are on these bits and things, and I think we've not. So basically we've got a bit set. Every single time we indent, we use the next bit along, and we're basically just saying if it's an array or not. And if it's an array or not, in here when we write the start of a field, we can choose between to say designated array initializers or designated field initializer. And we're simply just doing it that way. Yeah, we're not going to support all the crazy stuff you can do with C where you can chain it on, because that's more complicated and it makes sense if we do a simpler version of it. But this is meant to be a take one. Oh, for crying out loud, what happened here? Did it overflow? Oh, that's for the array, isn't it? Field name must be provided for all non-root types. Oh. Right, where's this line? Field must be provided for all. Bin field start, we do that check anyway. Yeah, we should get back to saying either you have that or this. Yeah, we moved the assert inside the thing here. Inside this function here. So this one is saying we must not have a field name for root types. So if you have a field name, all the indent is 0. So that same logic here needs to be repeated here for the array as well. Okay, it's made things a little bit cleaner, which is nice. So let's go ahead and carry on. Let's gen that. Oh, still got a problem, unfortunately. Strut field requires a field name. 1156. Damn it. So we didn't put a field name in here. So that should return true, right? Indent is equal to 0, right? Surely it must be. No, because it would have gone into here. Crap, and we wouldn't have set this bit yet. Oh, that's going to do -1 and underflow as well, damn it. That's a bit problematic, not going to lie. Maybe the field start should come after. No, we'll wrap it in a function. Sorry, in an if statement. What's up with my brain today? I'm so damn tired. Right, if statement. There we go. So, hopefully that works. I need to take a quick break in a minute. Oh. Right, so we must not have a field name for root types. Right, I changed the condition and really changed what the assertion was actually about, so the string should have changed too. So this assert should really be so this assert says struct field requires a field name. And we're trying to assert that we must so if we have a field name or indent is 0, so we're saying that the field name must exist for non-root types. So that means then, but on an array that's not true. Is that true? So if you're inside an array, you know what? We're not just going to have that assertion in there anymore. That's fine. So if we don't do that, okay. That should fix the logic. Be a bit neater as well, which is good, hopefully. What's wrong with giving the field names fields? Yeah, so basically it doesn't reflect the actual type. So it's actually an array. So where it says dot fields here, like this is dot. Right, let me change it around. Let me. Right, it hasn't been able to co-generate a new one. This is a fields array. So number of fields 7, fields array, and it's just an array of fields. So this is really, should just be like that, right? Just an array of structures. I wonder why I messed up on here. Strut field requires a name, so that is for 1156. Damn it. Why is he thinking it's a strut? Oh, because it's the first one, isn't it? Yeah, so you want to say or w ident equals 0. Finally, back to CSON file, give it a reload. Boom. Right, so for some reason we're getting a bit of an ident, an indent now here, and yeah, so before, yeah, this wasn't really happening. Maybe in general it should just be like if w indent. Just do nothing, man. And then this doesn't have to exist. Neither does this silly logic here. And that should fix it. Right, so hopefully, bit of a reload. Right, it's good. So this is all looking good now. Got 7 fields here, right? 3, 6, 7. You know, the names correctly, they got commas. Right, it's looking good. This is incorrect though now. So we said this is an array. So I've put so because this is an array of these, it's a user error from me using the CSON writer. Because I've started an array and gone over all the structures, this shouldn't really have a name. So that's fine. And then we can simply skip to the file there, give it a reload. Cool. So this is all good now. Happy with that one. Go to the next one. That all seems good as well. This is correct, right? Before this was looking like array syntax, but it's looking much better. Very nice. That's cool. See, something that we are missing is enumerations. We haven't. So either we print out the enum as a number, or we actually print it as a string. And I think we should really print out enums as a string. And maybe we should look into maybe doing small arrays and grouping them up on to a single line. So if the array, we should have a way to say, hey, make this array serialize out to a single line. Because that would be, yeah, it should probably be helpful. Because you might have a field which has like 3 array values or whatever, and it'd just be nice if it was not going down a new line every time. But we're getting pretty close to just enums and then look into that nicer array formatting, and that this should be the writer done. And then we can write a reader at some point. Right, I'm just going to go ahead and fetch another drink, and then we'll get going on that one. Right, BRB. Hey, Knots, good to see you. Welcome, welcome. I'll be back in a minute. I'm just taking a short break, so Right, welcome back everyone. How's it going? Man, I'm so damn tired. You should skip this CS stuff. Oh wait, I'm missing. How much time it took you to be this good? 14, 15 years now. Yeah, it's trial and error and talking to people, asking, asking people how they got to where they are and things they recommend. Um, but yeah, HTML, CSS, and JavaScript is, it for some reason, when I was Googling like 15 years ago, whatever, how do I get into programming? All I was finding was how to learn JavaScript and stuff like that. Yeah, I don't really know what is the best way to start learn programming. All I know is I did that way. I'm not a fan of those technologies these days, but maybe just learning what if statements are and what for loops are and just wrapping your brain around that. I think JavaScript is probably a good language for that type of stuff. Just learning control flow, functions. But after that sort of stuff, if you really do not want to be doing web programming and want to be doing something more like systems programming or whatever it is, go and move over to that after you understand the basic concepts of programming. We're always interested in computer graphics. I always wanted to make games, and computer graphics sort of do that. I never really understood it was a field that you could do, and the problem is I went to school and I went to college to do a university course, and I wasn't really, I even did like photography and computer design for like art, but the problem, I always knew these things existed, right? People would make 3D models, or they would, or they would program 3D, 3D, 3D games and stuff. But I never really understood how you even get started in it. So I was basically just like, yeah, it took me a while to really find out how to get started in it, really. It took a lot of time. So I first fell into JavaScript, basically, because that was easiest thing I could find at that time for some reason. I have no idea. Right, so if we want to do enums, we'll probably just encode the enum value out as a value, right? So we'll probably just write another one called enum, and it just literally is like the string one. So this assumes you already have, the types ahead of time. Yeah, so value. So this would not include the string quotes, Cool. So that's going to be out. I don't need to test it. We've already seen the other one working before without the quotes. So that'll be all right. What else are we kind of wanting to do with this CSON thing? I would like to see if we could get an array of stuff all end up being on one line. So yeah. People trust JavaScript a lot, myself included, but they're in the browser. Some people on the ease of sharing web pages. Yeah. Like the language is actually like quite error prone as well. You know, but yeah, it's definitely like very easy to get started in. That's for sure. But how's it going, Davros? How you been? Now today you can get MScript and you can get C in the browser as well. Yeah, you can, and also WebAssembly as well. You know, I was looking into like scripting. You know, people do like scripting languages and that. The reason why you do it is to the reason why you do scripting languages is because you want a mod for your game to be like confined or whatever. So it doesn't sort of like index out of memory and then like crash your game or something like this. It just crashes the mod. And I was looking into like the Z editor, you know, the text editor, Z. So what they use for plugins in their editor is WebAssembly. They actually use WebAssembly for extensions. So they have a little interpreter which runs in there and, you know, does the extensions in WebAssembly. And it did get me thinking, like, nowadays, there is already a portable, interpretable language target called WebAssembly. And the spec is there. And you don't really have to, you know, it's not a big thing to implement. You can write an interpreter pretty easily, probably one of those weekend projects. So realistically, you could have like a C, you could have people write their mods for your game in C, Rust, or whatever they want. They just target your C API. And then it just compiles to WebAssembly. And then the mod can run in confinement and you're not dealing with Lua. It's quite interesting, but I'm not really sure if I want like a scripting thing in my game or not. But I was just thinking about it, just like, maybe this is possible. And you can also JIT the thing as well. Though if you write a JIT, it's not too hard. You can write a simple one at least. That just gets rid of the interpreter loop. Could be interesting. But yeah, that's what I was thinking about yesterday. Trying to practice art more recently whilst adding normal maps to my demo. I found an easy done bug with my lights plus shadows, fixing it to improve the look of it. Cool. My shadows were mirrored in X compared to my lighting. Oh. Right, 3 out of 4 of my faces of the vertical cube were in shadow. Oh. Strange. That's cool though. Nice. Lights and shadows make things look way better. That's cool. But yeah, the art side of thing, this is why like I want to like just build the technology for my game and then sort of get core game loop done, and then like let me focus on the game and let other people do art, because I can definitely do art. I know I'm capable. I took art in school, but I know that I'm just going to be spending way too much time on it and not really making the game, you know, in the programming sense, not making the game. So I think I might outsource the artwork for my project, really, because my art's probably gonna be quite bad for a while as well if I did it. It's take too much time, you know. Yeah, so we want to have a way to say, like, if it's an array, do you make the well, it could not just be for an array, right? It could be for anything, like an array or a structure. We could have a boolean to say, hey, don't do a new line when you end your fields. That should be quite easy. So you want to say so if you don't do a new line, so the way that I'm going to look at it is, we would want to do it if the structure type is very small, right? Maybe it's like 1 or 2 fields or something like that, and they're both by value, right? They're not another structure in there. So we can work this out ahead of time when we do the code generator. Or if it's an array, which is the element type is just like an integer or something, like a basic type. So that should be something we can do in the code generator, and that should be nice and easy. So what we need to know is like, hey, where, at what indent did we decide to not at what indent did we decide to do a sort of no lines, no new lines? No new lines at indent, something like that. So we'll have like an invalid value, which would be U32 max. I want to try to compete with ProArtist, but dabbing more with Blender is definitely getting me further than just downloading free whatever free assets out there. And I don't want to spend cash money on this. That's cool. That makes sense. And all real world artists I know have wife and kid and feed these days and need money. That's very true. Yeah, they do. If they want to work in their spare time, they want to work and earn money. Yep, it makes sense. Yeah, definitely it will be end up paying for it, but I would need some. I would either need funding at that point, or I would need to give someone slice of the pie, which I need to figure out as and when. So basically when we start a strut or we start an array, we need to go, well, I could just turn off the new lines and turn them back on again. That's probably the better API. Like it's code gen, right? I can do that. New lines. So by default, we'll want new lines. Excuse me, so we do the new lines. Like here, for instance, right? So we want new line, put char. If W want new lines. Maybe in streaming you can find art streamers that will collaborate on good terms. Yeah, maybe. I think I've had in the past people approach for little games I've been working on. It does happen. That is true. And if I get to the point and advertise it, it will probably more likely happen. Start an array, want new lines, right? You know, this type of stuff is not typically good, as you know, it's branches, but oh well. Are any more new lines going around? Here we go. When you end a field or on a new line. So if you don't want a new line, typically you put a space to make it look a little bit nicer. Yeah, it's also quite expensive if you try and pay for someone to work on your project, because like if you go and work already, right, and you have a day job and you earn a certain wage, and then you want to pay for someone in your spare time to work on your project, it's like, you know, you're either paying them less money than you earn, or you're paying, you know what I mean? It's just like, and you're not paying them that much money, or you're paying them like the money that you've literally gone out and earned. So yeah, you got to have savings or like, or investment to really have like someone work on art for you. You know, it's quite a lot of money, I imagine. Especially if you want someone good. But I guess it also just depends if someone's willing. The price people are willing to work for, isn't it, as well? Right, I think that's good. So we would have wanted new lines. Let's test this out. This would be pretty cool. So we did it. CSON. Let's do the quick reload. Man, I'm so damn tired. My brain is failing. So it did nothing, and that's what we wanted to see. Right, it still does the new lines. It defaulted to new lines. So I did forget to put the API in. Hang on a minute. All right, it's going to be easy peasy. We're just going to set it right because we're not going to be using this thing directly. So you can enable a state, disable a state, and command. W, more new lines. You know, the field is technically public, but whatever. So now we've got this new lovely function, which does one line of code. So what we can do is have a bit of a play. So all of these fields, let's just whack them all on one line and see what happens. So we're going to go A. No. And then we restore it afterwards. Right, so let's hop over to the encoder file, or the CSON file. Do a lovely reload. So it's still done the indenting. It's not what we wanted, right? We should look at that one. And then it didn't really... Yeah. So what the hell went on there? So indenting is obviously not what we want to do. Right. Here we go. Yeah, so if we don't want any new lines, if not want new lines, we're just gonna do a lovely return, okay? Yeah, so why then did CSON, why did this array, right? Why did this array not do a new line? Right. So it's as if you want the new line to be re-enabled on the last. It's just a bit silly. So maybe the field start should put the new line in. Field start should put the new line. If you start a field, it will put the new line in. Yeah. That's where we're going wrong. So rather than doing it at the end of the structure or array open bracket, we do it at the start of a field. So yes, rather than doing it here and here, so we'll delete this one. Instead, we do it field start new line. So where's the indent used? So that means we won't need the new line. Where else do we want new lines? We wouldn't need it when we do it at field end then either. So that means if we, yeah, so this if statement actually just gets moved here like this. So where else is indent being used? Enter structure, indent, but you don't want it to indent if you don't want any new lines. But you would like it to put a space down, maybe? Yeah, you'd like it to put a space here instead. But the space has gone down here at field start. So really, this function should be called. That'll put a space in then return. I think that's right. Let's give that a gen. Hopefully, we've got it good. Let's do a reload. Looking all right. So we've said for this array, I don't want any new lines. And what it's gone and done is failed a bit, I think. So it's put all 7 fields. It's a bit much, to be honest. Let's not bother looking at this one. This one's got 2 fields, way easier. So it puts 1 field down, right? Trailing commas, that's cool. We accept that. There's one field, another field, and then it was like, didn't. There's an indent going on there and everything. So, yeah, because we put the new line when you start a new field, but the new line should also be there when you start a new array element, right? So we wouldn't have started an array element. Yeah, so it should have really. Right, so I've put this new line in the wrong place. So it can't be a field start. All right, let's have a bit of a think. So we used to put it when you would place this down, and then at the end of every comma as well. In every field, we would say it needs a new line. But then what would happen is that when you say I want a new line and I don't want a new line, change that setting, it wouldn't be respected in the right places. But now it's just not getting the new lines being inserted when you end a thing. So I think when you close something, it still needs to put the new lines in. Yeah, that's what's missing. So when you close, come on. Yeah, so we need this. We still actually need this when you close. So we need it for the indent anyway. You know what, I should just go into indent then. Right, it technically doesn't really make too much sense, but right. So want new lines, else a space, and then return for the space. Cool, let's give that one a go, hopefully. CSON, reload. Looking better. Still a bit messed up though. And that's because... Damn it. When did we end the new lines, the want new lines thing? Encode. Excuse me. On the array end. So it would have done the structure end already. And that's what we're seeing is on new line, isn't it? Yeah, why the hell is that doing that? Oh, right, it's an array. Ah. Why? Cool, that'll do it. Had those in the wrong place. Right, CSON, reload, and kaboom. Yeah, you've really got to put it in the right place. But again, it's code generated, so I'm not too fussed about this being... Hopefully that works out. Right, that looks good. So it's able to do it here. Nice. And then we can undo the state. Yes, Rowena. Cool. So what we've got now is a CSON file. It's C like JSON. You know, it supports integers, floats. Well, I haven't really tested floats, but strings, enums, and we're able to write a file out. This was the easiest one. So the next one that we want to do is be able to read one in. So we want to figure out like, yeah, we want to do that in the next stream, is write a reader. So the reader is going to be different because, yeah, we've got to somehow, see, I don't know if we're going to need a special reader type. So I want to think about this off stream. I think we might not want, yeah, maybe we should think about it now for a second. So when we read this file, we're going to be having, so I think sometimes we're going to bring these types up and actually make some structures from them. Other times we might want an API where we don't make structures from them and it's a bit manual maybe. Yeah. Which one is it? Yeah, so we declare these structures and we're going to code generate these structures right in actual C code, and they're obviously going to use these types here and not the encoded range of these types. This would just be a float 32, but when it's encoded as a binary file, it gets packed down like that. Yeah, so when we read from the text file, it'll, go into this data structure basically automatically. But we might want an API where you can maybe resolve it through a callback, maybe if you want the speed. Because you might want to convert it on the fly after you've read it, you convert it into the more of the other data type. But I'm not sure if we would need that one, to be honest. Because sometimes you have IDs on disk which are different to the IDs that are in memory. So you have like a data format structure which is kind of different. The copying it into a temporary piece of memory and then converting it again is a bit of a waste sometimes. But maybe it's okay. But yeah, when we read it, we're probably just going to have a bunch of typed functions calling other typed functions based on the type information, but it's going to be hard coded through the code generator, obviously. But the code generator produces the hard coded code. So we could, be quite easy to debug. We put breakpoints in there, print stuff out, and it'll be nice. So realistically, from a CSON reader, what do we need from that? So if it's just a structure type, we just need to be able to read. We need to take we need to be able to take a string name and get a field back, and get a value back. So you need to be able to say probably read. You could probably do a read uint and stuff like that. My concern is they might not exist in some of them. So for structures, you probably need to say, maybe the idea is that you translate. Maybe maybe just check if it exists. Nah, it's a bit weird. No, maybe you need a reader. Where it basically iterates over all of the... So you've got a structure now, and then you go next field, and it gives you back the name. You check to make sure the name matches the one of the ones you're expecting, and then you encode that as, and then you decode the value, right? So then you say read value of int, and then you go to the next one. So it's like a for loop or something. Yeah, so you just go over line by, field by field, decode. Then I guess at the end, if it's a structure, we can guarantee that they all exist, or something like this. Yeah, so I guess for the reader, we will need a CSON reader, but it's going to be like an iterative API, where you begin decoding the structure type or whatever. Next. Well, while you're doing the next, you can say get me its value as a string, and it will try to do it. If it fails, it will, sorry, turn this string into an int. If that fails, yeah, we can have an error or something. So yeah, we will need a CSON reader, but it'll be like an iterative API instead. Yeah, that'll work. So we're going to need one. We'll start this next stream. Which API layer are you going to be using the reader? Feed into the editor. So the plan is, right, well, this code generator. So this CSON reader and writers, we're not going to be using those directly. We'll just code generate it from that reflection information that we've parsed in this encoder file. So we've parsed this up. We have type information on it now, and we'll just code generate these readers. So where are we using so your next question is probably where are we using the encoder and decoder stuff for, like, what are we using it? Well, we're going to be using it in the editor. We've got the encoder plan. So we've got things like a level file for like tests, right? This is going to be like a procedurally generated game, but I want it to build some little things to test out, like rendering, and test out little behaviors of game logic. So I want to be able to save those and load them back in. With arrays of entities from the entity component system that we've built. So that entity system that we've built probably needs to generate its own encoder file. Then that will code gen the encoding code. So that'd be pretty cool. We have a code generator using a code generator. So it's like code generatorception, And then we have like materials, like, roughness, metalness, just basic stuff like that. And albedo for like an ellipsoid, so we can give it a color, and material properties. We haven't got any texture support yet, that'll come later. When we build models, we want to have a history of what it took to build that model. So we'll have a lovely array of model edits. So it's like, oh, I've placed down an ellipsoid, oh, I've deleted an ellipsoid. So this means we can play it back, we can boot up the editor and be able to undo stuff that we did in our previous session, which would be pretty cool. We've got a BVH tree that we want to encode out. So that will probably be binary file, because that's release builds only, probably. Maybe. But yeah, serialized BVH tree for the model. We've got a whole bunch of other stuff to do the editor, basically like what it takes to build a character, animation, stuff like that. And then so other than like saving stuff out for files, basically, we'll probably want to be able to use it for the GPU as well. So if we go over to the the GPU shared section, I think it is. No, graphics shared. No. Graphics internal shared now. Yep. So we've got a thing called a BVH node. And I wrote a whole bunch of packing code for it manually. Here it is. So I end up it was down to like 16 bytes, but then I couldn't fit it all in, so I ended up changing it again. But I don't have to keep fiddling around with this. So I'm thinking I can use this encoder system to define it in a nice, easy way with like, I want to pack this float down into these ranges and it automatically generates the code for it. It just makes code like this, So I don't have to, this is quite error prone, and if I want to change it, I've got to get all the numbers right again. And so this is another use case for it. What else? Oh, and for networking as well. Like whenever I want to do some networking, I want a way to define some packets, and the packets want to obviously pack stuff down into as small of an area as possible. So we have this syntax here to say, hey, take a float and quantize it down into this range using 8 bits. But we also have this sort of table thing, which is taken from flat buffers. It's quite a cool idea. Everything in here is optional. So if you don't provide any data for it, it means it is its default value, right? So you don't have to encode it out into the binary thing, right? So we're probably going to need like union support as well when we do that, but we can add that later on. So those are basically the 3 main use cases: files, networking, and GPU packing. Yeah, this is what it's going to be used for. So it's going to be pretty sweet. It's going to be awesome. Very useful. So when I come back to doing the rendering again, we'll have a new tool in our arsenal to help us do some crazy stuff on the GPU. So next stream will be Tuesday, guys. 7:30 p.m. GMT +1. Same time on Thursday, and then 4 hours ago next Sunday. Next stream we'll do the reader for the CSON stuff. And then we'll do the binary reader and binary writer. So sorry, binary writer then binary reader. And then we'll probably do the metadata side of things after that. And then we'll do the code generating side and get it all code genned. And yeah, so still a fair bit to do, but this is still good progress nevertheless. At least got a text file written out now. We've got the parser done. So let's find someone to raid quickly. Yeah, remember Discord if you want to come and hang out in the meantime. And yeah, thank you for everyone who's supporting me via subs or Ko-Fi. Really appreciate it, guys. Really appreciate you all. Cannot find any one of my followers, at least. Thank you, Cap. I appreciate it. Yeah, just chipping away at it. It will get done. It will get done. No worries, sir, Kenny. No worries, sir. Why am I this far down in the list? Right, I might just bail, to be fair. I'm gonna go and eat some food. And then collapse in bed. Right. Have a good start to your work week, guys. I'll see you all in a future one.